Let's get started changing the filter caps on the silver Jubilee. Now I'm trying something a little bit different in this video. I've got the lav mic, since it's an Omni, actually mounted a clip to the tripod rather than to my shirt, so I don't have the cable drifting everywhere. Let's see how it works. I'm going to start with this one for the preamp, and the first thing I need to do is loosen all these nuts on these jacks on the back. We'll get these out of our way so we have good access here. Let's see. These plastic nuts are actually on here pretty tight for the most part. And so I'm going to use a tool to start them. Just get that initial turn, because they're compressed. And it's really hard to do by hand if they're tightened properly, which these were, aside from the first one, which was the foot switch jack. That was a little bit loose. Now I can do this by hand. Once I get them out of the way, I'll double check the lighting and focus in the area where the filter cap is. So hopefully you'll be able to see things. I would need a really elaborate boom arm to position the camera optimally for you guys to see this while I work, and I don't have that. Now, it's important when I do this that I remove these washers and put them to the side so they don't fall off and get lost. These compression washers are what help the nut really squeeze everything to the chassis and get it tight. All right, so that'll work for now. Here's the cap. It has two red positives and the chassis ground connection. And we verified that there's no voltage on these caps with the amp out of standby into play position. That way any voltage on any cap will be shared with the others. 66 millivolts on that one. 66 millivolts all the way across the board, so I don't have to worry about getting zapped. Now, these old leads are just tucked through the holes in the old caps and soldered, so nothing elaborate will be required to get them out. And there's enough excess length that I have some slack, so it's nice. Not always the case. And in this case, it doesn't matter which one goes where, because they're the same value cap, and the ground here is shared. Looks like the ground wire is also just tucked through, which is actually good for our purposes, though it's not the best build quality. Let me get some of this excess solder out so we can see it. That's good enough. I'll make sure that you guys are seeing enough of what I want you to see. All right, so this ground wire, first of all, I'm just going to pull straight out, and we can reuse it. All right, to get this cap physically out, marshals are always fun. Either the screw is facing you or the nut is facing you, or neither one is, and you've got to stand on your head and rub your belly to access things. On this one, it's pretty simple. I can access the nut from the side facing me. It's a 6.5 millimeter nut. It's very important that you have the right size tools for all the hardware, especially with the brass hardware on old Marshalls, because it's real easy to strip it out. If you really get a close but not exact imperial socket, it might work, but you might damage things. You want it to mate on all surfaces. I've got that loosened, and this should just pull right out. Sometimes you gotta help the clamp remember that it's possible for it to open. So I'm not going to show this because it's pretty simple, but I just get a flathead screwdriver in between the two positions on the clamp and kind of twist and pull the clamp out open. And that usually does the trick, but of course now that I've got this thing on camera, it's arguing with me. The nut came off, that's how loose it is. Let me fish that out real quick. Let's see how badly I moved the tripod in the process. We're good, I guess. All right, put the nut to the side. What's happened is the old clamp has embedded itself into the plastic of this old LCR. Okay, you can kind of see where it was clamping into the insulation. Even with the clamp being loose, it did not want to break that contact. Let me put the screw back where it goes. This is real exciting, I know. Get that nut started again so it doesn't wander off during this process and get misplaced. I've just found some bubble wrap on the floor. I'm sorry that the chair I use is so noisy. It's one of those Aeron Wonder chairs that everyone was selling for so much money in the 2000s in the knots. And I found a company that was going out of business and clearing out all their office furniture, and I got it for a good price. It has an unfortunate stain, which I have to tell people was not mine. And it makes noises, but it's very comfortable. And as I spend a lot of my time in this chair doing these videos, my back likes it. All right, now this is the ground connection, and this is the one that really needs to be examined to make sure it's good. So again, with the same 6.5 millimeter nut, and I'll need to get a flathead screw on the other side, a small flathead screwdriver. Be careful with the brass on these things. All right, so the screwdriver is held in place on the other side. Arrgh. A, I don't like brass hardware for anything. B, I think it's criminal that people use flathead screws when Phillips and posi drives exist and are infinitely superior in every way. Not to mention steel is better in every way for these purposes than brass. But anyway, all right, I've got that loose. Put the screw to the side and the nut to the side. Now let's focus on these bits. So we've got a washer here. Let me make sure this is focusing. That washer contacts the chassis, and the chassis is a ground point, and it's got this black oxide tooth washer, then the brass nut. So you've got 4 different kinds of metal here. And when different metals contact each other, you can have chemical processes that lead to oxidization, and other funky things can happen. And it's important to clean them all off with any corrosion. A little bit of dirt and funk in here. And a little bit on here. So I will clean all this off with some deoxit after I get in there with just a little bit of a sandpaper. Here's an 800 grit wet dry. I only need a small amount, so I'm not trying to do anything radical. I just want to make sure that surface is clean. Since I have a very small area to deal with, I fold it up. All right, so In the past, I had a Dremel attachment that was perfect for this. I could burnish a very small area. And that one wore out. And I've been unable to find the exact replacement. And all the other ones I found have been too large and either remove too much material from too large an area or leave ugly marks. But in a chassis that's overall in good shape like this, it doesn't take a lot. Just that. And then some deoxit. And we'll do it on this as well. I'll spray that over the trash can. And I need to get some more paper towels. I'll be right back. All right, now here I just want to blot it up. I don't want to wipe. If I wipe, I can get fibers from the paper towel in the surface area. So just blotting excess deoxit up will do the job. Same for this bit of steel on the ground lug. That's not as pretty as I'd like. So I'm going to hit it with a bit of that. Be a little more vigorous on this. I'm not sure if this is going to focus. It does make a difference. Even the resistance of less than an ohm can cause a lot of weird behaviors in amplifiers in general. And in a higher gain circuit, it can be bad. Now, deoxit that one more time, both sides. That's better. Now I know that when these surfaces mate, there's going to be good contact. And everything will be clean. As I drop things. And then we go to the metal oxide washer, which was here just a second ago. Here it is. Sorry. And then the nut with that factory black paint on top. Move the ground wire close to the I need a little more slack out first. And do like this. All right, now I'll go from the other side on that flathead screw. And get this as tight as this freaking brass screw will allow without stripping it or chewing up the slot and the screw. All right, that is tight. Put the new cap in. The old LCR is larger than the new F&T. The new F&T weighs more than the old LCR. Go figure. Anyway. And the old LCR was physically slightly bigger in diameter. Line that up like that. And then I will partially tighten it at the nut till it begins to grab so it won't fall. Like that. A little bit more. Don't want to clamp it until I have it exactly where I want it. Don't want to fully clamp it until I have it exactly where I want it. There we go. Because I want to make sure that I have a good connection on that ground wire to the ground terminal of the cap without any, I want a little bit of slack, but I don't want any tension on it. And I wanted to use a little bit of the excess length because the negative lead is closer than on the LCRs, so I can get that partial wrap. And that makes me happy. So let me tighten that up. I've got it so that the plastic surface here is just about flush with the chassis, which is not always possible to do perfectly because of the way the clamps work. This will be good. Let's get that really good and tight. All right, let's redo our ground. All right, so we've got that partial wrap at about 270 degrees. And I heated everything up before I flowed the solder to it. And while there's not a big ball of solder there, that is a very solid connection. Now let's redo these positives. Now these positives just go to the other underside of the preamp board. And this twist that they partially did from the factory isn't really necessary for DC, but it does give some additional mechanical support. So I'm going to extend the twist a little bit. And since we have that slack, I'm going to snip off the old ends that were just tucked in the holes and strip it back a little bit and do a partial wrap on each one. And know that I have a very solid connection for the future. If the wire did not have the slack, I would reuse the old. While it is not optimal, it certainly has held up in this particular amp over the years, but I just like to know that I'm making it rock solid. All right, so each one gets a twist. I'll take a little bit more off that one, just a wee bit. And then I'll tin the ends, like I did on those speaker wires on that deluxe reverb yesterday. And just kind of crimp it against itself before soldering. This one has one loose strand, but that won't affect anything. All right. Time to put all these back. I do them one bunch at a time because these little plastic washers like to go flying. Actually, before I do that, I'm going to give that part of the rear panel a bit of a clean. I already, and I'll show this later, I already experimented with a tiny little corner of this chassis. Different Marshall faceplates in different eras have different considerations in terms of cleaning. Plexis you can clean with pretty much just a little bit of gentle warm water because it's just clear plastic and all the writings on the back. On the metal panels, don't get them wet under any circumstance because the silkscreen will come off with any moisture whatsoever, including the sweat of a player's hand on stage. On this Silver Jubilee with a silver panel, they used a different silk screening ink or process, and I found by careful experimentation in a corner where nothing crucial was, that WD-40 did not affect that silk screen so long as there was I don't use any real pressure. And so I'm using that on the rear panel, which gets off all the dust and just little bits of smudge from the decades. Not trying to make the amp look brand new. This is not a cosmetic restoration, but certainly clean is nice. There are parts of the amp where cleanliness affects tone, like I did on that ground there. But there are places where it's just nice to have things clean where possible. Let's put these back on. We'll tighten them by hand first, and later I'll go back and make sure that they're all as tight as the plastic will allow. And as I do this on each batch of 2 or 3 at a time, I'm looking at the solder joints to make sure that there's nothing on each jack that needs to be reflowed. This amp's in pretty good shape as far as that goes, but a lot of these amps over the years, the nuts come loose, the nuts get lost, people don't realize it, people don't care. And in use then, when the nut's not there or the nut's loose, you can get strain on the solder connections, so it's common to find bad solder joints in such places. So by doing it relatively slowly like this, I can take a look at each solder connection and make sure that nothing needs to be redone. But these all look good so far. And I will clean them later. Well, I'll show one now, so I don't have to show the whole process later. While I'm in this area and the camera's set up. Let's see, which one is the camera really looking at right now? We'll do the center return jacks right now. Because those are common places to lose signal. So, get a guitar cable. When these plugs are inserted, the jack opens up over here. Might be easier to do. Well, I can't really show it without taking these out. I'm not going to do that, but the jacks and their normals open up on one side. And that's where you spray the stuff. I'm going to do this later, actually, because it's better if I tilt the whole chassis on its side so I have better access there and gravity works with me. But I'll show it my fingers. Basically, there's the normal piece of metal, which is on one side, and then the tip or ring or sleeve on the other side. And when nothing's plugged in, they're like that. You plug in a cable, plug in a cord, and it goes like that, and it opens up. And so when I plug in like that, they're open. and I can get some deoxit on those metal surfaces. Then by unplugging and plugging back in, it does that and kind of works it out. In extreme cases, I'll go in there with a little bit of that 800 grit or 1000 grit wet dry sandpaper and get that in there, but it's usually not necessary. But that gets at any old corrosion or dirt out, so you have good mating when they're closed. Like if you're using it with nothing plugged in, you want those to have very good contacts, because all your signal from the preamp goes through the send and return jacks, and that's a common place to lose signal. Anyway, I will do that later. Let's move on down to the other two dual filter caps. Now the process for these is exactly the same, though it's harder to see because the power jack and this fuse. Unless I run into something really unusual, I'm just going to show you this before, which looks just like the preamp one did, only maybe you can see this cap has some bumps in it where it's beginning to leak inside. I showed that in the first video on this app. And then I'll show you the after. But if I run into anything weird in the process, I'll show that, but hopefully we won't. All right, here's something worth showing. Apparently I misspoke early in the video. I didn't misspeak, I was just wrong. I was complaining about the brass hardware because almost all Marshalls to this day use brass hardware on the reissues and the JCM 800s and stuff. But no, this one's steel. Not the world's best quality steel, but it's steel. And, you know, it is a flathead, so still awful. But anyway, this one has got actual rust here. So, I mean, this is stuff that's all hidden beneath the mounting hardware until this process happens. And, I mean, it's just makes a huge difference in the sound and reliability of the amp when everything is clean. So again, and again here for this filter cap ground, which has all these wires on it, and the AC safety ground. Those just both have a little bit of corrosion and dirt, so same process. Well, the battle of the bulge has been won. So all three main filter caps, which are 3 dual section filter caps, so there's a total of 1, 2, 3, 4, 5 main filter cap stages in this app. So that's all done. It's time to move on to the stuff on the PCB, all the electrolytic capacitors there, and get this thing really ready for prime time. All right, all the electrolytics on the board have been changed with some really nice fichets across the board, no pun intended. And as to how I do it, I've shown how I remove PCB components in multiple videos in the past. So I don't want this thing to get too long or too repetitive. And as you can see, with some of the moisture on these wafers, all the pots have been cleaned and lubricated. And it's time to put it together, double check the bias, and see how it sounds. All right, one thing I thought I was recording, it didn't end up recording. I've got all the nuts on the front side of these pots set the same distance from the leading edge, the front plane of the shafts, so that when all the knobs are in place, they'll all be on the same plane, same distance from the front panel. And then I went behind with this small thickness wrench and tightened all the nuts from the rear, which means I could get it really tight without having to worry about scratching the front surface. So while all the pot shafts are very slightly different increments from the rear of the panel. The front side, they're all the same. So when the knobs are in place, they should all be level. And I'll put the knobs on once I'm sure everything else is good, because we may have to pull this board out if there's something else in here that needs changing. And this spaghetti I mentioned on the lead dress, we'll neaten that up later. First, I'm going to see if the bias is good, what condition the tubes are in, if we need to change any tubes, etc. So let's dive into that next. Okay, before I powered it up, I checked, and the mains fuse had blown. I had not checked that yet, because this is the first time I was even thinking about changing, powering on the amp after this cap had been changed. And we need to get some new output tubes for this. Let's see, let me look at my notes here. The bias supply is the same, feeding each grid of the output tubes at the point where the bias source goes through the grid leak resistors, the 220Ks. But by the time it reaches the grid of each output tube, there's a 2-volt difference in the grid voltage. And that could be leaking DC through one of these phase inverter output caps, though I suspect not in this case, because these output tubes are also very mismatched with each other. Sorry about the noise in the background. There's a tree service across the street taking some limbs off an oak or something, and they're going to be my companion today. The tube on the left, with the current limiter in place, that's a little bit artificially low, is biasing at 36% idle dissipation, and the one on the right is at 20%. That's a big mismatch, almost 20%. That's not going to magically get better if I take the current limiter off and give this thing full voltage and full current potential. That's only going to get worse. So given the fact that these are very mismatched and there is a lot of hum and crackle, which goes away, does not go away if I pull the phase inverter. So there's nothing in the preamp at this point. These tubes are mismatched, are noisy. It's possible we have grid leakage, so I'm going to get another pair of EL34s and put in here and see where we're at with that. All right, with a pair of JJ EL34s in, some test ones, the bias discrepancy went away, so they're both, well, at least the grid voltage stays the same at pin 5 on each one. The issue now is that this tube consistently draws half the current of this tube, no matter the tubes. But a lot of the noise went away. So WasBad tubes on those old ancient Sovtecs this came in with. But the issue now, which is going to be throwing off everything, is that this screen voltage is 30 volts higher than this screen voltage. And it's going to be this resistor, or this resistor. I imagine it's this one. So both these 1K screen grid resistors are about to get changed out, and then we'll see if the tubes are biasing correctly with the same screen voltage on each, because that's just too wide an idle dissipation difference between the two tubes. With the new Vishay low mass 5-watt 1K screen grid resistors, the screen voltage is the same at both tubes. Everything is good. The current limiter is off. I have the amp idling now at about, it's 60% on this one and 58% on this one. I'm sorry, 60 on this one, 58 on this one. So we'll just call it 59%. These are not the final output tubes this amp will have. These are a test pair I have. So I will reset the bias finally when the real tubes are in. All the hum's gone. A lot of extraneous buzzes are gone. Now this is with the master at 0. So I'm happy with the output section. I know that all the filter caps are good. I know that the components involved in the bias supply and the screen supply are good. And we have no problem built into a tube socket. There's no carbon from any arcing. We don't seem to have any leaking DC from the phase inverter output caps, which can also throw off a bias. Though, you know, to be fair, sometimes that takes 30 minutes to a couple of hours to exhibit. So, you know, I'll keep an eye on that. But now it's time to see what it sounds like. So just plugged in with the telly. So I'm trying to remember how all the controls work on a Silver Jubilee. All right, good. We don't have a lot of any noise on the pots. No big microphonics. That's good. Now this with the volume on the guitar at 0, and we have this buzz. So let me put the guitar down for a second and see how much of that buzz goes away with shielding and how much of that is something I've got to go in there and deal with. And some of that's going to be lead dress. Where's my little pointer thing? Just moving grids away from heaters can do an awful lot about that. We'll move this grid down towards the heater. This is just as I move the wires around in the preamp here. And I'll be addressing a lot of that just through lead dress and shortening things and controlling where they go. But where is that big piece of metal I have here? So some of it's addressed by shielding, other bits a bit noisy. Now just because these preamp tubes aren't microphonic doesn't mean that they're behaving right. And I will take this one stage at a time. But I'm touching the cathode here and it's ejecting noise. I hear that squeal if I touch that grid. That is an amp which is not stable. So that grid wire will get shortened, redirected, possibly replaced with some shielded wire because it's acting as a noise antenna right now and it can oscillate and cause all kinds of nasties at full volume. And we don't want that. So I'm going to start with the clean channel because I can hear a buzz in the background with the clean channel here. Even with the preamp volume off, the preamp volume's all the way down, just the master up, I hear a buzz. Turn the master down, it's quiet. So that tells me it's not in the phase inverter or output, that's good. So I've got a targeted range of where to look next, and I will do that after I have some lunch.